Hi class, so in this video I'm going to talk to you about balancing nuclear reactions. So first you have to know that a chemical reaction is reactants becoming products. Reactants are what you put into the chemical reaction. A chemical reaction happens, that's how, and we explain that using an arrow. And products is what we make, what comes out of a chemical reaction. So when you see chemical reactions with an arrow here, you know that the arrow means there's some rearrangement of usually atoms, but in our case that we're going to be talking about here, about protons, neutrons, and electrons moving around. So there are two kinds of nuclear reactions. There's fission reactions and there's fusion reactions. Fission is when you break up a nucleus to make something new. So usually it means you take one atom and you make it two or more atoms. A fusion reaction is when you take two or more atoms and you make one, or you make fewer. So this is where you put atoms together. So you'll see this figure, and this should be very familiar to you from the handout that I gave you on balancing nuclear reactions. There are four kinds of particles that are made as a result of nuclear reactions, made or used. And so you have alpha particles, which are basically helium atoms. You notice that they have a +2 charge, which means that they have two protons. And so that's a helium atom, and it has a mass of 4. So you can also represent it this way, right? Atomic number of 2, protons 2, and a mass of 4, protons plus neutrons, is 4. So there's 2 neutrons. You can have beta particle from an emission, and that would be a negative charge and have no mass, and that would be an electron. And you have basically the positive version of an electron. It has a positive charge but no mass, and that's called a positron. And then we have gamma particles, which are very high energy. They have no charge and no mass. So if we look at some examples here, we notice that the reactant side and the product side always have to be equal, because there's an important law that you have to know. It's called the law of conservation. Of matter. And this states that you can't destroy mass and you can't create mass. Mass is conserved. Mass cannot be created or destroyed. So you'll see that here. You see that on the left side there are 92 protons, and on the right side, on the product side, there's 92 protons. 90 plus 2 equals 92. So you can think of the arrow as an equal sign. And you look at the same thing at the top. There are 238 protons and neutrons. And you add these two together, 4 plus 234, you get 238. And notice that the 90, the number of protons, tells you it's thorium, and the 2 tells you it's helium from the periodic table, just like 92 is uranium. So, again, you can see that in this fission reaction, you have 7 plus -1, which is 7 minus 1, equals 6. And 14 plus 0 equals 0. And you notice that a nitrogen atom is being made and an electron is being released. In this reaction, you can see a positron is being released. 5 plus 1 equals 6. And 11 plus 0 equals 11. And again, 5 protons means that it's boron. 6 protons means that it's carbon. Remember, 1 doesn't mean it's hydrogen, because this has no mass. So it has to be a positron. And again, you can see from this example that there's a negative charge on a particle that has no mass, so it's an electron. So 7 plus negative 1 is 6. 14 plus 0 is 14. In this example, you can see that there are 2 gamma particles being made. So you notice a different thing in this problem is that there's a 2 in the front. This is called a coefficient. It tells you the number of that kind of particle that there is. So gamma particles, which is written like this, have no mass and no charge. And there's 2 of them being made because you see there's 2 of them on the left side here. And the 1 and the negative 1 cancel out to make 0, and then the zeros obviously at the top also make 0. So you have 2 in the front, 2 of these gamma particles being made. This is a fusion reaction. You notice that this rubidium atom is combining with an electron, and the mass is decreasing by 1, so it's 37 plus negative 1 equals 36, and of course 81 plus 0 is 81. And now that it has 36 protons in it, it's a krypton atom. Same thing, very similar here. You're adding a neutron. It's a fusion reaction. When it combines, you're just adding 1 to the mass of cobalt. Notice it's still cobalt because it has 27 protons, but you're adding 1 because of the neutron being added. 1 to the mass number. So here's one where we have to solve it, just like the homework problems. We have 88 protons on the left and 2 protons on the right, so we know that the number on the bottom has to be 86. And there's a 226 on the top over here, the mass number. Here there's 4, so this has to be 222. So we have to look at which atom is number 86 on the periodic table. So I bring up my periodic table here, and number 86 is over here, and it's radon, Rn. So I write capital R, little n. Let's do another one. We have this fission reaction. We notice that there is 8 protons on the left and 7 on the right, so there's a 1 that goes down here. We know that the masses are the same, 15 and 15, so we know that there has to be a 0 up here. So what has a positive 1 charge but no mass has to be a positron. And in the last example here, we see that we have 53 protons on the left and negative 1 as a charge on the right, so this has to be a 54 down here. Right, remember, treat the arrow like an equal sign. And there is a 131 mass on the reactant side and a 0 on the product side, so this has to be 131 here. So again, we look at our periodic table and look for 54. And 54 is right here. It's xenon. We write capital X, little e, and there's our answer. And we see that an electron is being released. So essentially, you have to know that there for this topic. So when you're ready to take the quiz, you will know how to balance a nuclear reaction, and you have to know the difference between fission and fusion, and know the 4 kinds of particles that were in that chart in the beginning of this video and at the top of your handout. I hope this was helpful, and best of luck. See you in class.